As the second orbital flight of Starship approaches, the interest of rocket enthusiasts is on the rise. They're not only curious about Starship's immediate upgrades and developments, but also about what'll happen after Starship reaches orbit, especially Super Heavy's ability to return for reuse. According to SpaceX's long-standing plan, Super Heavy will be caught and returned to the launch pad. However, until now, many still believe that the safer and more efficient method for SpaceX is the sea landing on the Droneship, a method that Falcon 9 is doing masterfully. So, how will Super Heavy land on a drone ship offshore? Why didn't SpaceX choose to take this approach? Stay tuned as we dive into this and more in today's episode of Alphatech. Since at least late 2020, SpaceX CEO Elon Musk has been floating the idea of catching Starships and Super Heavy boosters out of the sky as an alternative to having the several dozen-ton steel rockets using basic legs to land on the ground. That's the method of catching the Super Heavy booster with the arms of the launch tower. This is a considerably gentler process than the suicide burn SpaceX routinely uses on Falcon. By decelerating as quickly as possible and making landing burns as short as possible, Falcon saves a considerable amount of propellant during recovery, extra propellant that, if otherwise required, would effectively increase Falcon's dry mass and decrease its payload to orbit. In the Super Heavy catch Musk shared, the booster actually appears to be landing, just on an incredibly small patch of steel on the tower's Mechazilla arms instead of a concrete pad on the ground. Aside from the tiny bit of lateral motion, the arms appear motionless during the catch, making it more of a landing. Further, Super Heavy is shown decelerating rather slowly throughout the simulation and appears to hover for almost 10 seconds near the end. That slow, cautious descent and even slower touchdown may be necessary because of how incredibly accurate Super Heavy has to be to land on a pair of hardpoints with inches of lateral margin for error and maybe a few square feet of usable surface area. Aside from demanding accurate rotational control, even the slightest lateral deviation would cause the booster to topple off the pillars, and in the case of the Super Heavy, fall about 100 feet onto concrete, where it would obviously explode. What that slow descent and final hover means is that the Super Heavy landing shown would likely cost significantly more propellant than a Falcon-style suicide burn. Propellant has mass, so Super Heavy would likely need to burn at least 5 to 10 tons more to carefully land on arms that aren't actively matching the booster's position and velocity. Ironically, SpaceX could probably quite easily add rudimentary fixed legs, removing most of the bad aspects of Falcon's legs to Super Heavy with a mass budget of 10 tons. But even if SpaceX were to make those legs as simple, dumb, and reliable as physically possible, and they wound up weighing 20 tons total, the inherent physics of rocketry means that adding 20 tons to Super Heavy's likely 200-ton dry mass would only reduce the rocket's payload to orbit by about 3 to 5 tons or 1 to 3%. Further, per Musk's argument that landing on the arms would enhance the speed of the reuse, it's difficult to see how landing Super Heavy or Starship in the exact same corridor, but on the ground instead of on the arms, would change anything. If Super Heavy is accurate enough to land on a few square meters of steel, it must inherently be accurate enough to land within the far larger breadth of those arms. The only process landing on the arms would clearly remove is reattaching the arms to a landed booster or ship, which it's impossible to imagine would save more than a handful of minutes or maybe an hour of work. Put simply, while Starbase's launch tower arms will undoubtedly be useful for quickly lifting and stacking Super Heavy and Starship, it's looking more and more likely that those arms are as a landing platform will at best be an inferior alternative to basic Falcon-style landings. More importantly, even if everything works perfectly, the arms actually cooperate with boosters to catch them, and it's possible for Super Heavy to avoid hovering and use a more efficient suicide burn. The apparent best-case scenario of all that effort is marginally faster reuse and perhaps a 5% increase in payload to orbit. At this point, many opinions suggest that SpaceX should consider a landing method for basic reuse that they've long been successful with Falcon 9, and that's landing on a drone ship at sea. To be honest, this is also a possibility for SpaceX's Super Heavy. Why do I say possibility? About 3 years ago, SpaceX showed an interest in landing Super Heavy on a drone ship similar to the Falcon 9 booster, and at that time, it was referred to as Marine Recovery Systems for the Starship program. A conventional launch mission will leave the stage with close to as little fuel as possible by the time it detaches in order to be efficient. That's sort of correct, but in fact, having enough fuel to make that return would be wasted money. Not just the fuel itself, but the fuel to carry that fuel up in the first place. So the barge in the ocean is an economic issue. It's far cheaper to bring the rocket back on the ship than to fly it back with fuel. So they can load only as much fuel as they'll need to deliver the payload and then mostly fall and glide for a powered landing on the barge. If you can launch your rocket 10 times instead of paying $100 million a launch, you can spend something like $10 million a launch. If you could relaunch 100 times, you could spend something like $1 million a launch. This is a big change in cost. It means a lot more business and people could benefit from space-related technologies. If costs come down enough, it could also mean that we'll see companies sending a lot of people to places like the Moon, Mars, or asteroids to mine them for their valuable minerals and water. If we save our dollars, it wouldn't be unthinkable that we could buy a ticket someday in the not-too-distant future and have a vacation on the Moon or even move to Mars. Of course, it's kind of cool that a rocket could land automatically on a tiny landing pad out in the middle of the ocean. That's some good navigation to reduce the overload of increasingly crowded land launch pads. As for launching from a place where they could come down on land, the issue is that if something goes wrong. Sure, there are parts of the world that are basically desert, where there wouldn't be a risk if a rocket crashed, but mostly they aren't as near to the equator as coastal launch sites presently being used. Depending on where in the flight something went wrong, debris could still fall outside the desert. But a big reason is that if the rocket crashes in the ocean, there's a decent chance it can be recovered sufficiently intact that the remains can be studied for helping to assess what went wrong. While if it crashes on land, it's going to be smashed and scattered. Thus, until rockets are as dependable as airliners, launching over the ocean is much more preferable. This diagram does a great job of showing what happens when Falcon 9 lands on the Droneship instead of land, which SpaceX can also apply to their Super Heavy booster. But nothing's absolute. This method still has its drawbacks. After all, it can't be denied that landing on recovering a giant rocket boosters at sea is inherently difficult, risky, and time-consuming. Although landing on the sea can reduce costs, it's not by much. Moreover, it's not efficient in quickly turning around the rocket for the next launch. SpaceX would need time to bring it back to the launch pad, reducing the turnaround frequency of Super Heavy. When SpaceX is serious about establishing a base on Mars, they'll launch hundreds of Starships and possibly thousands of fuel-carrying ships into orbit over an extended period. Super Heavy needs to ensure readiness to immediately launch a new Starship. However, so long as at-sea recovery costs less than a few $1,000,000, there's always a chance that certain launch profiles could be drastically simplified and end up cheaper by the occasional at-sea booster landing. Furthermore, if SpaceX has multiple prototypes of Super Heavy that can be launched consecutively, the time for transporting and maintaining the Super Heavy back from the sea will not significantly impact SpaceX's launch rhythm. Although this is just a private perspective, one cannot deny it's an exciting prospect. The ship is still waiting for the FAA's final verdict for its second orbital flight. After a long wait, we now just hope it won't be delayed again. SpaceX says no to limits as Elon continuously innovates technology to bring humans deeper into space. This is why it's so ahead of the competition that will never catch up. For example, while other spacecraft manufacturers are still struggling to follow SpaceX's lead in reusable rockets, SpaceX is already on to what is really an insane idea: mid-air rocket catching using the Mechazilla launch tower. The technology of catching rockets mid-air, as ridiculous as it sounds, but Mechazilla is gradually proving its potential for success. What Mechazilla just did with Starship is shocking more than you might think. Recently, there has been musing that SpaceX has become an accidental monopoly in the space launch business. Elon Musk has dominated the launching of things and even people into space. Indeed, SpaceX has become the go-to rocket company for a variety of services. The SpaceX Crew Dragon is the sole commercial American ride for astronauts to low Earth orbit. The Falcon 9 is the cheapest and most reliable way any customer has to put anything into Earth orbit. SpaceX is also deploying the Starlink communication system, designed to provide voice, text, and internet directly from space throughout the world. Let's not forget Starship, the monster rocket now under development at the SpaceX Starbase facility in Boca Chica, Texas. When the Starship is operational, it will be able to launch immense payloads into low Earth orbit, land people and cargo on the Moon, and fulfill Elon's dream of establishing a settlement on Mars. These things will happen provided that government regulators authorize more test flights. That's not the only reason we can be confident they'll succeed. The ability to achieve this ambitious goal depends on their development. We might think that producing more and testing more will prove their progress. Yes, that's not wrong, but it's not enough. The crucial aspect is not how many tests they conduct, but how much they have upgraded through those tests. The first orbital launch on April 20th ended in a spectacular explosion. But to assess accumulation and identify issues, Starship must prove itself in the second launch. Meanwhile, as the next launch hasn't happened yet, what we look at to see SpaceX's progress is the activities at Starbase. An outstanding activity bringing us excitement and highlighting SpaceX's learning process in the Starship program is the stacking of 2 rocket stages together. Wait, do you think it's a simple thing? A small step? Well, Let me show you that it is indeed a small but crucial step for the Starship program. Until now, the concept of stacking our Starship has always been a slow, careful process involving the arms of the launch tower to ensure the combination is correct and perfect. There were even cases where human intervention was needed in the stacking process for greater accuracy. However, things have changed in the last 6 months, only for Ship 25 and Booster 9. SpaceX has stacked them 4 times as of today. This number is nearly equal to the total number of stacking SpaceX performed previously for Ship 20B4 and Ship 24B7, which was 6 times in total. Not only that, but the stacking time has also seen significant development. We no longer have to wait nearly 2 hours to witness a complete 120-meter high Starship. In just 1/3 of that time, SpaceX has been able to quickly complete this process. Here's a fantastic time-lapse video showing each necessary step to achieve proper alignment for the stacking of Starship 25 and Booster 9. It's insane how the crane and connectors can move it in such small increments. Immediately afterwards, within a few hours, SpaceX promptly conducted a fuel test for the complete Starship, bringing it closer to the wet dress rehearsal test. This is a huge change compared to 6 months ago, demonstrating SpaceX's rapid learning and development, and the process will be a crucial point to serve Elon's goal of continuous launches in the future. Why is that? The upper stage of Starship has a fuel tank large enough to place objects into a stable orbit and return. If it intends to carry its payload to Mars, the Moon, or a Lagrange point, where we have the greatest need for a vehicle capable of transporting loads of hundreds of tons, it needs to consume more fuel. You would want to complete the job as quickly as possible if you have anything living there, because the more supplies they need to get through the refueling process, the more fuel they have to take to know where they're going. The only current way we have to provide it is with the amount of fuel being used by oil tankers launched from the same base that Starship has done. In theory, they could assemble all of them at once and move them out one pad at a time, but that means they'll need more than a dozen stages below and upper stages to support each upper stage of Starship, and the potential cost advantage of the system will largely evaporate. The ideal cost configuration would have to be 1 Starship, 1 oil tanker, and 1 booster, with the latter 2 flying multiple times a day. If successful, it could bring rocket launch costs to unprecedented lows. However, it won't be efficient if the overall turnaround time for checks, stacking, and fueling to the oil tanker takes too long. While currently, there's not much that can be done to reduce the time needed for checks and fueling. That's why the increasing frequency of stacking over time will help SpaceX optimize a part of that time to achieve the most efficient performance for Starship. In fact, the success of this rapid stacking cannot be discussed without acknowledging the significant contribution of the enormous launch tower lovingly called Mechazilla. It's Elon Musk's quirky creation since he announced catching the Starship with chopsticks. Honestly, many of us still can't fully grasp Elon's intentions when building Mechazilla, as it looks unlike anything built before. Not to keep you waiting, recent revelations about it have been disclosed in Walter Isaacson's best-selling biography on Elon Musk. The story of the chopsticks had begun 8 months earlier at the end of 2020 when the SpaceX team was discussing the landing legs being planned for Starship. Musk's guiding principle was rapid reusability, which he often declared was the holy grail for making humans a spacefaring civilization. In other words, rockets should be like airplanes. They should take off, land, and then take off again as soon as possible. The Falcon 9 had become the world's only rapid reusable rocket. The video feeds of this fiery yet gentle landing still made Musk leap from his chair. Nevertheless, he was not enamored with the landing legs being planned for Starship's booster. They added weight, thus cutting the size of the payloads the booster could lift. "Why don't we try to use the tower to catch it?" he asked. He was referring to the tower that holds the rocket on the launch pad. Musk had already come up with the idea of using that tower to stack the rocket. It had a set of arms that could pick up the first stage booster, place it on the launch mount, then pick up the second stage spacecraft and place it atop the booster. Now, he was suggesting that these arms could also be used to catch the booster when it returned to Earth. It was a wild idea, and there was a lot of consternation in the room. If the booster comes back down to the tower and crashes into it, you can't launch the next rocket for a long time, Bill Riley says. But we agreed to study different ways to do it. A few weeks later, just after Christmas 2020, the team gathered to brainstorm. Most engineers argued against trying to use the tower to catch the booster. The stacking arms were already dangerously complex. After more than an hour of argument, a consensus was forming to stick with the old idea of putting landing legs on the booster. But Stephen Harlow, the vehicle engineering director, kept arguing for the more audacious approach. "We have this tower, so why not try to use it?" After another hour of debate, Musk stepped in. "Harlow, you're on board with this plan," he said. So why don't you be in charge of it? As soon as he made this decision, Musk switched into silly humor mode. He began laughing about the scene in The Karate Kid where the karate master, Mr. Miyagi, uses a pair of chopsticks to catch a fly. The tower arms, Musk said, would be called the chopsticks, and he dubbed the whole tower Mechazilla. He celebrated with a tweet. We're going to try and catch the booster with the launch tower arm. When asked by a follower why he didn't just use the landing legs, Musk responded, legs would certainly work, but the best part is no part. On a hot Wednesday afternoon in late July 2021, the final segment of Mechazilla with the movable chopstick arms was put in place at the Boca Chica launch site. When his team showed him an animation of the device, Musk got excited. Kick ass, he shouted. The viewership on this one is going to be huge. He found a 2-minute clip from The Karate Kid and tweeted it out from his iPhone. SpaceX will try to catch the largest ever flying object with robot chopsticks, he said. Success is not guaranteed, but excitement is. Do you dare to take on a challenge? Catching an object weighing a few kilograms thrown from the 3rd or 4th floor with your bare hands? I bet not many would dare to try that. Now, consider doing the same with a truly massive object weighing hundreds of tons and containing potentially explosive fuel falling out of the sky. It's undoubtedly a challenging and terrifying prospect. However, SpaceX has chosen to do the seemingly impossible. Catch the Starship rocket mid-air using their specially designed Mechazilla launch tower. It's too difficult and complex that no other company in the world even thought about attempting it, let alone achieving it like SpaceX has. It sounds insane. I mean, I haven't even seen a sci-fi movie that does this, you know? Elon Musk himself even had to admit that. And there's more to come in the latest Mechazilla updates from Elon Musk. During Thursday's International Astronautical Congress in Azerbaijan, Elon Musk unveiled intriguing insights into the future of interplanetary travel. He not only unveiled new information about Starship, but also delved into fascinating details about the possibility of catching both Starship and booster mid-air.
But we have a giant custom-designed tower with massive mechanical arms that will literally try to catch the booster and catch the ship.
With a colossal tower soaring to an astonishing height of 440 feet, this giant beast isn't just for show. It's a central feature in SpaceX's audacious plan to launch the Starship spacecraft into orbit. Its arms function as colossal chopsticks. The tower will guide the super heavy booster in Starship, the largest flying object ever, back to Earth. It's not just about catching a massive piece of metal. It's about ensuring a gentle landing to safeguard the precious technology on board and to avoid any risks to human lives or property damage. During the first flights, SpaceX planned to focus on landing the ship in the Pacific Ocean. The ship's successful landing at a precise position in the water will serve as a signal to attempt the catching process. Therefore, when it comes to the next steps, Elon Musk expresses great confidence in the catching process of the launch tower. So, both the booster and the ship come back to the launch site. Yeah, that's what I mean by the in fact. I mean the thing that is a success. We need a giant tower with customized arms to lift the booster and the ship onto the launch pad. We're going to absolutely need it. We can technically do it with humongous cranes on a low-wind day. For a booster or Starship catch, the rocket will approach the tower, enter the gap between the splayed arms, hover in place while the arms close around it, and eventually come to rest on hard points that appear to offer about as much surface area as a coffee table. Based on simulation of the process shown by Elon Musk, the arms will mainly move in one dimension, open or close, and can't actually grab the rocket in any real sense. As built and shown, they are closer to a tiny fixed landing platform capable of minor last-second positional adjustments. Eventually, the chopsticks could shave a small amount of time off of post-recovery processing, removing the need for a crane or the same arms to attach to a landed booster or ship. They could also shave off the dry mass required for landing legs, though all interplanetary ships will still need legs. However, they will also inherently make proving their own efficacy a nightmare. By all appearances, the current recovery mechanisms on the arm and the landing hardpoints on ships and boosters mean that a catch could fail if either stage is more than a foot or two from the perfect bullseye or rotated a few degrees in the wrong direction. This raises an interesting question to ponder. Can Starship accurately hit such a narrow landing target? Normally, we witness Falcon 9 descending quite rapidly during landings. This is commonly referred to as the suicide burn, as finding the right timing is crucial. If initiated too late, the rocket might crash forcefully and explode. If ignited too early, it uses up excessive fuel or even rises back and flips over, resulting in a detonation. We've witnessed both scenarios with the Falcons in the past. The rationale behind this is twofold. Firstly, to use as little fuel as possible, hovering even for a few seconds requires a significant fuel reserve. Secondly, an empty Falcon 9 is very lightweight, approximately 550 kilograms, while the Merlin engines are powerful, making it challenging to decelerate adequately with a booster alone. With the method SpaceX has devised, even the tiniest error could easily end with a massive, pressurized, partially fueled rocket destroying the chopsticks and plummeting a few hundred feet to the ground, guaranteeing an explosion that could damage surrounding infrastructure or even start fires. In the event of larger anomalies during a landing attempt, Starship or Super Heavy could accidentally impact the launch tower, damaging or even outright destroying the skyscraper-sized structure. This is certainly a plausible scenario, and at least Elon's aware of this challenge. The rocket will need to be robust and operate flawlessly during the ascent and acceleration phases to meet the requirements for the catch attempt. Musk emphasized the certainty of precise landing capabilities through thrust control, a technology SpaceX has successfully implemented in the past. Importantly, the rocket must undergo a hover phase combined with the motion of the arms. This setup seems to be the perfect answer to the question of landing within the narrow constraints of Starship. Once again, we can compare it to the Falcon 9, the workhorse that can land in a relatively small circle even on an unmanned ship floating in the ocean. When the Falcon rocket lands on the ground, it almost always hits the bullseye on the landing pad. The Falcon can only steer with grid fins, lacks gimbaled engines, and has no ability to hover gracefully. If we look at Blue Origin's new Shepard booster, it can perform some very slow ground landings with controlled descent using fins and gliding, but it still lacks gimbaled engine control. So, with all the advanced technology in Starship, the combination of grid fins, landing legs, and the ability to hold in midair will likely enable it to hover. However, the fuel efficiency of using thrust to hover is a concern. Musk suggested that the idea of having the rocket briefly hop up upon its return. The overarching goal is not just reusability, but rapid reusability, and bringing the rocket back to the launch site is considered the most rapid approach. In principle, the booster returns very rapidly due to the high thrust-to-weight ratio, approximately 1.3 to 1.4. The staging ratio, currently about 3 to 1 in favor of the booster, means that the propellant on the booster to propel the ship is about 3 to 1 in the current version, trending closer to 2 to 1 in future versions. This shift directs more of the delta V to the ship's side. As a result, the booster uses up its propellant quickly, trending towards only about 100 seconds of booster flight. The booster then swiftly flips around, boosts back to the launch site, and lands, making the return to the launch site in about 4 or 5 minutes. This rapid turnaround is achieved through the booster's fast landing, either caught by the arms or landed on the surface within 5 minutes of the flight. After the landing, the booster returns to the launch stand and propellant refilling can begin. The ship's return timeline is contingent on the booster's orbital parameters. Depending on the launch azimuth and inclination, there is a possibility of a single orbit, allowing the ship to come back within about an hour. A fantastic development for Starship. Can't wait for that pivotal moment. Although the Mechazilla tower has not yet performed its spectacular performance, at the present time, it's performing part of its function better and better. Let me remind you that the first time the launch tower performed stacking with Starship, it took over 3 hours from start to complete mating of the rocket, aligning and joining them together completely. However, over time, SpaceX has learned a lot. As you can see, recently they fully stacked Ship 25 and Booster 9 multiple times, and the entire process took just a bit over a half an hour. It's also impressive just how little uncontrolled movement was visible as Starship hung in the air hundreds of feet above the ground. Virtually no swaying was visible, meaning that the arms were doing their job of stabilizing the massive rockets in a situation where even a gentle breeze could make stacking Starship with a crane far too risky. Finally, we don't know what developments will come next, but every step SpaceX takes will certainly be a mark that brings advantages to Starship's journey. And that's all for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section down below. Your feedback is very important to us and helps us make better videos for you. Thank you so much for watching and see you next time.